Hi, I'm Victor Barocas from the Department of Biomedical Engineering at the University of Minnesota and a member of the SPINEWORK network. And I'm going to talk to you briefly about digital image correlation to measure deformation, particularly in soft tissue. So if you ask why would we be interested in this, soft tissues deform when you load them. So if I bend my nose, the tissue moves around. It's usually fairly straightforward to measure the applied load. So if you're going to do any sort of test on a person or a sample, it's fairly easy to have a load cell that measures how hard you're pushing or pulling. Much more difficult is measuring how much the tissue changes shape in response or moves around in response. So again, if I had a spring or a weight that I attached to my nose, I'd have to turn my head sideways. I know the force, but where's everything going? That can be harder to measure. So the tool I want to talk about is digital image correlation, or DIC. It's a computational method that determines how much a sample has deformed between one image and another. So you have two images. We know that the sample has moved or deformed between the two images. We want to quantify that. And most DIC software will output for each point in the image the displacement of the point, so how much the point has moved, and the deformation, meaning the stretch and rotation. So has the tissue been stretched? Has it been rotated? In what direction have these things happened? Those will be typical measurements that you'll get from the tool. And the operating principle is fairly straightforward, although it took some years for these to get commoditized to the point where everyone can use them. The idea is you take a small patch of tissue in the initial image, so here it is, and you rotate it and stretch it and move it around, excuse me, until it matches what is seen in the final image. And I should say this is taken from the website of a company that makes some of this software. And when we know that, then we know how that point has moved and rotated. And we do that at all the points, and we end up with a map. And you just keep trying different motions. There are various algorithms, but the basic idea is if I take this red box, where is it in this image? Where do we get the strongest correlation in the digital image? That's why it's called digital image correlation. Okay. Here's an example. So this is a basilar artery. It's one of the arteries in the back of your head. This is removed from a patient who had a brain aneurysm. The tissue has been speckled with blue dye so you can see it more easily. And this is a very important feature of image tracking. You have to have some texture to the image. Obviously, if it was all white, you wouldn't be able to tell where it moved because everything would correlate with everything else. So you have this blue gunk here. And as the sample stretches, you can see the dye move and it will tell you how the tissue is deforming. And I'm just going to run the video now. And you can see this sample is being stretched. I'll run it again. And you can see the motion because you can see how the blue areas are moving. And then that's what the code does when it calculates the digital image correlation. So based on that, this is just an example. And I just took some data that the postdoc who gave me the image, the video, gave me some data. So this is the horizontal stretch and this is the vertical stretch in the tissue as a function of position. So 0 means the tissue is not being stretched. 0.4 means it's being stretched 40% longer. As I said, you could also get displacement, shear, area, rotation. But what you'll notice is, like in this area here, the tissue is stretching a lot in these yellow regions, but not so much here in this blue region. So the digital image correlation can tell us the overall stretch, but also the stretch in different regions within the tissue. So if that's important to you, this is a very valuable tool. Um, it's not a trivial tool to use. There are some challenges, of course. Speckling to get good image texture is something of an art. And poor speckling can lead to gaps in the measured field. So if you don't get a nice sort of modeled image that's hard to track. Out of plane motion can be very tricky to manage. So if in that case, it's a tissue sample that's been mounted, but if you're looking at a sample that can move in 3 dimensions, that can be very tricky to manage. We'll talk about that in a moment. And you also can't track what you can't see. So with a sample that's being mounted for testing in the lab, that's not really an issue. But if you're talking about something in a person, if your instrument that is causing the deformation is in the way of your imaging, for example, then you can't image the area. You don't get an image, and then you can't track it. So you have to be careful about those challenges. Finally, I just want to have a list here, and you can, of course, pause this and write these down or cut and paste them. But here are some sources of the software. So ncore.com provides a free open source software that runs in MATLAB. And Trillion also has free standalone software. So these are free software. You can download them and use them. See how you like them. The Solov Lab. This is a scientist named Dana Solov. She started doing this when she was a postdoc at MIT and is now works in one of the universities in Israel, I believe. They have a multi-camera DIC that can use stereo images to track 3D surfaces. So the idea is you have multiple cameras and you take all of their images and you process them, and that allows you not just to tell how things are moving in a plane, but how they're moving in 3D space. Now, it's only a surface, right? Because they're just cameras. You can't see into the tissue, but you could track the motion of things on the surface of the body, and that's what they do. CorrelatedSolution.com, they have some really nice software. It also does 3D surfaces. And I have a friend who works in medtech and he swears by it. He says it's the best tracking software out there, but it's not free. So if you have a lot of money and you're trying to figure out how to spend it, it's worth looking into. But if you don't have very much money or you're just starting out, I would recommend looking at some of the free software. That's all I have. I hope that this has been helpful, and I encourage you to think about using image correlation tools as a way to track motion.